Come back, Math-2s. We're going to do our next one, third practice, which this time we're going to be using probabilities or counting methods to calculate some probabilities. This is probably the more fun chapter section of this chapter. I think it is. So just remember that when we're calculating probabilities, I'm just going to write it here on the side. A nice little formula we're going to use. The probability of this event happening is going to be you could either use probabilities or numbers here. The number of event A happening divided by the total number of the sample set. But you can also separate it if you wanted to. You can have it so that the probability of this happening is the probability of event A happening. Or so you actually couldn't do that way. It would just be kind of pointless to do that because that would just be the same. I was thinking about a different one for later on. So the financial institution here randomly generates a 3-digit security code for the background credit cards. She's expecting her credit card to arrive in the mail. Determine the probability that her card will consist of the 3 different even digits. Okay, so let's first of all think of the whole sample space. We have 3 digits. That's kind of weird. Sorry, just 1 second. Let's get that in there. Okay. Now we're using here, I'm going to use the fundamental counting principle. And I have 3 digits. I can go from 0 to 9. So I have 10 digits for each one of these. So my total number of different digits, I can have 0, 0, 0, and 1, 1, 1. This is my total number. It's going to be 10 times 10 times 10. So that's going to be 1,000 different codes I can have in the back of there. But she specifically wants 3 different even numbers. So there are 5 even numbers, 2, 4, 6, 8, 10, which would be 0. So I would consider 0 to be the most even number, so that would count. So she has 5 choices for that first one, but she wants a different one for the next one. So if I chose like a 4, I would have 4 choices left. If I chose another one, I would only have 3 choices left. So in this case, I have 20 times 3, so I only have 60 possible numbers here. I'm going to reduce this down. Just pull my calculator because why not? Math, enter, enter. She has a 3 out of 50 chance of getting something that just has even numbers in it. Not very likely. Okay, so you can see how we did that. We found the total number on the bottom. We found the total favorable outcomes on the top. We just divided and reduced it, and we got our probability. In a card game, Crazy Eights, we're dealt 8 cards from a standard deck, but determine the probability consists of exactly 4 jacks. Okay, so let's think about, first of all, how many different card combinations are there? Okay. Now I'm going to use, this case, I'm going to use combinations because I don't think it really matters what the order the cards happen to be. So I have 52 cards. And I want to choose 8 of them. So order doesn't matter. So I'm going to use combinations. I'm going to pull my calculator here. I'm going to go math, or actually 52 first. Math. Go over to probability. I don't know if you can see that there. It's backwards, but you're going to go over to probability, and then you're going to go down to NCR, and 8. So it's quite a bit here. So there are 752,538,150 different card combinations I can have if you have 8 cards. Now I want to know the probability of exactly 4 jacks. So that's all the jacks. Okay, so I want all the jacks. So I have 4 jacks. I want to choose all 4 of them. But then I still need 8 cards in my deck. So I've chosen all the 4 jacks. I'm just going to minus the 4 out. So I only have 48 cards left, and I need to choose 4 more. Okay, so let's just go through and punch my calculator here. So 48 choose 4 is 194,580. And 4 choose 4? 1. There's only one way to do that. You have all 4 jacks or not. Then it just times it by all the different ways I can have other cards with that. And then I'm going to reduce this down. Oh, I don't think I can in my calculator. Let's see. We could definitely reduce it by 10. Can I reduce it by any more than that? I can definitely reduce the top number a bunch of times. Let's just see what happens here. So I'm going to punch this in my calculator. the exact numbers. So I was just testing to see what I can divide that number by. Doesn't really work too well in my calculator. I get a kind of an ugly, I'm just going to leave this the way it is. Yeah. If you want to reduce it more, you can try. So maybe you can like say, okay, I could divide both of these by 10, which will get rid of these zeros here. So this simplifies just down a little bit nicer. A little bit nicer. I'm not saying that is nice here. Okay. Maybe you can reduce this down more. Doesn't look like I could divide them both by 2. The bottom one is not even. Because I can't divide by 2, I can't divide by 4, 8. I can't divide by any even number. Can't divide the top by 5. Right? That might be the lowest this goes. Okay. For a committee here, so we want to choose randomly a president, secretary, and treasurer. Now, because there's positions here, right? I'm going to think order matters. Up at the top here, I'm going to, because they just want to be in my hand, order does not. It's kind of a weird way to write that. Does not matter. Because there's positions, I'm going to say that order does matter. For this one. Okay. So the probability of this happening, let's call this event A, is the total number of committees. So of the committee, I have 10 people. I need to choose 3 or P3 of these because order matters of all 10. Okay. Let me just go here. We're going to use P this time because order mattered. So there's 720 committees I can create in total. But they want to place the 3 kids here. How many ways can I rearrange those 3 kids? In here, if I do the math on this, I'm probably going to get 6, but let's double check. Yeah, I'll get 6. 6 ways to rearrange those 3 kids in those 3 positions. So 3P3. And then I'm going to divide the 2 numbers, math enter, and say there's a 1 in 120 chance of this happening. It's a bit nicer number. What questions are here? Woo, 8 questions. All right. Jared's teacher has a pack of 6 different colors in his construction paper, or 9, sorry, why did I say 6? There's 9 different colors. She distributes 5 of the construction papers, each with a different color, to each student. Okay, so I'm saying there's 5 students. Oh, 5 sheets of construction paper, each with a different color to each student. Determine the probability that Jared will receive red, purple, blue, along with 2 any other colors. Okay, let's see what we have. So they're going to get 5 sheets of paper. That's important. There's 9 colors to choose from. Order doesn't matter. It doesn't matter if he has those papers in any specific order. He just has them. So it does not matter here. That order does not matter. So how many ways can I give the kid of the 9? How many ways can I give him 5 sheets of paper? So I'm going to go 9. Oops. 9C5. Okay, so I get 126 ways to do that. And then he wants, of these 3 very specific colors, he wants 3 of those 3 colors. That's just C through D. That's just going to be 1. If you ever do the math on that, it's going to be 1 times, there's supposed to be a little time sign there. He wants 2 other colors. Of how many sheets are there? So we used 3 up already. The teacher's not going to give him duplicates. So there's only 6 more colors here. So 6C2. 6C2. So it's like 15. So it's going to be a 15 to 126. It's going to be equal sign, sorry. I'm just going to divide it by 126. Go math, enter. Just double check to make sure that we can reduce this, and we can. 5 out of 42 chance. Have it. Cool. Okay. Pretty easy so far. So here Rochelle has a bunch of letters, and right now they can spell the word bookkeeper. She turns it face down, mixes them up, and asks Chris to arrange them and then turn them up. So he doesn't know how they turn up, so pretty random. If he spells bookkeeper, they win. So the fun part of this is there's only one way to win. You spell bookkeeper, right? There's only one way to spell bookkeeper. There's lots of ways that could possibly happen because a couple of O's here, a couple of E's here, 3 E's, 2 K's. I think that's all there is for that. So let's figure out how many ways I can remake this here. So I'm going to put big brackets here because this calculation is going to be a bit trickier. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is there 10 letters? 1, 2, 3, 4, 5. 1, 2, 3, 4. Yeah, so there's 10 letters. So there's 10 factorial ways of rearranging those 10 letters. But because there's repetition, we got to get rid of that repetition. So there's 2 O's, so I can have to divide by 2 factorial, which is just 2. Because there's 2 K's, I got to divide by 2 factorial. Because there's 3 E's, I got to divide by 3 factorial. So now I can go through this and figure that out. Math, 10 factorial, divide by 2 times 2 times 3 factorial 6. Yeah. So there's a 151,200 ways to rearrange those letters, and she has a 1 chance of doing that. There you go. Looking pretty good. Not very likely he'll win, but he could win. More likely than if it was if there wasn't any repetition, it'd be like a 1 in 3 million chance. But because you could repeat those O's, it reduces how many different ways you can rearrange those letters. 5 boys, 6 girls have signed up for a trip to Francophone artist to see a Francophone artist compete at a festival international de la chanson de Granby. Yeah, my French is definitely not any one of my languages. How about that? Only 4 students will be selected to go on the trip. Determine the probability that only boys will go. Okay, let's see. So remember, the probability is how many favorable outcomes divided by all the outcomes. So all the outcomes here, we have 5 and 6. Add those together. There's 11 in total. Okay, so I have 11 in total, and we can only choose 4 students to go. And I don't think there's any particular difference between when they get picked or how they get picked. So I'm thinking there's no order here. So when you see, so it's 330 different ways I can send these 11 kids. Okay, but I want only boys. So how many boys are there? There are 5 boys. I want to choose 4 of them. There you go. I think that's only 4. But let's double check. Was 5, my bad. Okay, I'm going to reduce it. 5 divided by 330. Math, enter, enter. So 1 in 66 chance of this happening. What's the probability? So we're doing probabilities here. What's the probability that there's an equal number of boys and girls on this trip? So of the 5 boys, I want to choose 2. Of the 6 girls, I want to choose 2. And we have the 330 from before. So this is the probability of this happening. So I'm just going to punch these in my calculator. That's 10. And that's 15. So this is 10. This is 15. I'm sorry. And 330. So 150 and 330. It's actually way more likely this will happen. Math, just less than 50%, but 5 out of 11. Just reduce those down. That there'll be more girls than boys on this trip. So we have to think of how many times there'll be more girls than boys. So we're going to be a bit more laborious here. I know there's a total at the bottom here. There's 330. So there's more boys than girls. So obviously it's not this one. Whereas half and half, it's obviously not the one above it when it's all boys. So to figure this one out, I'm going to think about all the different situations I have. So where are we again? There's 6 girls. Of the 6 girls, I want more girls. So 3 of them to be girls and the other one to be a boy. But I also have another situation. I'm going to add them together because this is like saying at least 3 girls. So I have one more situation where I have 6 girls and I choose all of them. So that's 4. If you want to put in here 5C0, that's not really going to do anything. Okay, let's see what we have here. 6C3. I'm sure there's other ways to do this. This is just the easiest way to do it. Remember, if you have any questions, always come to my Google Meet, ask me questions there. I have a bunch show up at random points. If those 2 times don't work for you, it's 100 plus 15, 115. Come at any time. My thing is usually open. So you can just pop in if I'm there, or just say hi, and I'll say hi back. Usually pretty fast if I'm there. If I'm not there, then I probably won't say hi back, but that's fine. Yeah. Ask me a couple questions. We'll pop in if you ever have any problems here. Erin has 3 tiles, or has tiles that can spell the word cabinet. She has selected 3 tiles at random. Determine the probability that these 3 tiles will have 2 vowels and 1 consonant. So let's first of all, she has 1, 2, 3, 4, 5, 6, 7 tiles, all different, so that's nice. I don't know, it's just 2 vowels and 1 consonant. Maybe order doesn't really matter. She just picked a bunch of random. Does she have 2 vowels or 1 consonant? So I'm going to say order doesn't matter, unless she said how many chances will have 2 vowels then 1 consonant. So let's just say order doesn't matter here. So 7C, and she picked 3 tiles. 3 tiles, so 7 through 3, so order doesn't matter. So 7, math, 3. It's a good thing I hit that button first. 35. And I want to know that she has 2 vowels and 1 consonant. So let's see. How many consonants do we have? Remember what a consonant is not a vowel. So C, B, N, and T. And the vowels are A, I, and E. So there's 3 vowels. I wonder how many ways I can have 2 of those. And then I have one more letter of the 4. There we go. So that's going to be 4 times something. Probably 6. Oh, I was way off. It's 2, 3. Oh, that makes sense. Remember we were saying before. Yeah, saying before. We'll talk about that because that was last 2 units ago. 12 divided by 35. Let's just double check. 12 over 35. So I can't really reduce that down. So that one's done. And there you go. Okay, yeah, I'm saying order doesn't matter because she didn't say that we have 2 vowels then 1 consonant. Like she's not telling this is the order it has to be in. So, or she's spelling out words. She's just selecting 3 tiles and they're in her hand at this point. Okay. Mr. Allen decides to purchase 10 lotto tickets. Okay. Hopefully I can win. At this point, I think it's at 70 million at this point during this video. So hopefully. How many favorable outcomes are there? So if each of these tickets has 6 different numbers, different combinations, and if there's only 1 prize, what's probably Mr. Allen winning? Well, I have 10 tickets. I'm assuming they're all different. So I have 10 chances of winning. Those are my favorable outcomes. But there are a lot of numbers here, from 1 to 49. There's only 49 numbers. 0 doesn't count. So that would be 50 numbers from 0 to 49. It's like 0 to 9 is 10. So this is only 49 numbers. And I want to choose, because it doesn't really matter the order, because they just get put in order later on, but I want to choose 6 numbers from that. So I'm going to take 6 numbers from that 49. So it's going to be a big number here. What was it? It's 1. No, what is this? 13,983,816. So I have a 10 in this number down here. Can't divide it by 5, but you definitely divide it by 2. So I'm just going to divide these numbers by 2 here. So 5 in 6.9 million chance of winning. Oh, I like those odds. I'm going to win. Probably not. All right, there we go. And that's the answers to that sheet. If you have any questions on it, make sure to come by to the Google Meets and ask me the questions there. All right, I'll see you in the next one. Bye.